Yeah, we want to go PowerPoint first. Boom, boom. Okay, math and finance. We're going to look at simple and compound interest, interest taking so many times per year, compounded continuously, annual percentage yield. I used to do, you're going to be the first class that doesn't have to do future value or present value. Even though they're really kind of cool to look at and do, there's so many mortgage calculators out on the internet and annuity calculators and stuff like that. You would never try to calculate this manually like what we would have to do in here, ever. Because it's so much easier to go out on the internet and figure it out on the internet. You know, most of this stuff, yes, you can go out to the internet, but you have to know a little bit of the math behind what's going on. But for this is the first year I've actually cut these two things out. So there you go. People in the past have hated it. Okay. Compound interest is this formula. A lot of times you'll see the amount equals the principal times 1 plus the rate to the number of years it's compounded for. That's compound annual interest. Now, we don't use this much very often, okay? We use compounded so many times per year. But let's use the compounded annually, okay? So this is annual simple interest and annual compound interest. Well, simple interest is interest equals principal times rate times time. I equals PRT. So my interest equals $5,000 times my rate 0.05 times my time for 10 years. So doing just simple interest, it doesn't compound at all. It just happens over time. If we take this times this times this, 10 times 0.05 is 0.5. 0.5 times 5,000 is $250. That would be the simple interest. That's how much interest you get in 10 years compounding it, or not compounding at all, just simple interest. Compound interest is much better. Compound interest is the amount that you have in the end equals the principal times 1 plus the rate, 1 plus the rate to the time power. Okay? So it would be 5,000 times 1.05 to the 10th power. Okay? So your interest rate over the 10 years is really small. 1.05 to the 10th power is small, but you're taking the interest every single year. So what happens is you have a total, then after the first year, you're adding that interest in it. Here, the interest is just added on at the end, so you have $5,250 is what you end up with. Well, here, if you do this one, somebody take 5,000 times 1.05 to the 10th power on your calculator. 5,000 times 1.05 to the 10th power. Okay. Would you rather have simple interest or compound interest? Obviously, compound interest. Okay? You want compound interest because after the first year, you're going to have 5,000 yada, yada, yada in there. But here, you're only taking the interest off the original $5,000 and calling it good. So compound, every year, you get more interest. Okay? All right. So now, you can get it compounded once a year, which isn't that great. Or you can get it compounded quarterly, which is how many times a year? 4 times a year. Monthly, which is how many times a year? 12 times. Daily, which is 365. Some people say the math works better if you only use 360. So some places daily is 360, some is 365. So we'll use 365 in here. So for compounded more than one time per year, the formula changes just slightly. You take the rate divided by the number of times it's compounded per year to the number of times it's compounded per year times the number of years. So you divide your rate by K and you multiply your time by K. Okay? That's the difference. So those of you who have been in personal finance, you should know this formula. Okay? You should have hit that in there. So this is compounded more than once a year. The basic compound interest formula was this one. R, there was no K here, and then no K up there. So let's see compounded monthly. Paul invests $400 at 8%, so it's 0.08 divided by the number of times it's compounded per year. In this case, it's 12. So it makes the interest rate really small, but then you take 12 times 5. Instead of taking the interest once per year for the 5 years, or just 5 times, you're taking the interest 60 times. So you're making your rate smaller, but you're compounding it 60 times, which actually goes your money faster. So 400 times, this is 1.0, and then it's 0.0667 something to the 60th power, something like that. If you do that on your calculator, you should get $595.94. $595.94. Okay? Now, you can compound it even more than that. You can compound it continuously. And this is where natural logarithms come in. Because the inverse of the natural log is e, which is called Euler's number. Because Euler was a mathematician that first started using E. E is approximately 2.7182881828459045. We had this discussion before in here, right? What about the President Andrew Jackson and so on, okay? That's how I remember that number. But E is compounded continuous. That's why it's a natural logarithm. It's a naturally occurring number for things continuously happen. So let's say Paul, instead of getting, because it was what, $595, I think, $595.94. Let's see if it's compounded continuously. So we take the $400 times e to the 0.08 times 5, or 400 times e to the 0.4 power. If you do that, it's not that much more money, but it's a little bit more money. How much money is that? What's 400 e to the 0.4 power? 400 times e to the 0.4. He made an extra dollar in something. Not that much when you're talking about this amount of money. But if you're talking about $1 million, it would be a decent chunk of money. Okay? So, compounded continuously is better. Annual percentage yield. You hear on, when banks are advertising how much their annual percentage yield that you come in and use their bank, is the percentage rate when compounded annually would would return the same as if you weren't compounding it. Or, yeah. So, what is the annual percentage rate if you're getting this month's interest compounded monthly? Okay. So, to figure this out, what we do is we take, if it's compounded, the annual interest rate, if it's not compounded monthly, would be this 5,000 times 1 plus the certain amount of interest rate. And we compare it to what we get when we take that interest at that interest rate. Okay? So we have to solve this. If we continue solving it, we get 0.0643 for x, which is 6.43%. So if you are getting 6.25% because you're compounding it monthly, if you'd be compounding it yearly, it would be 6.43%. So the reason why they use APY is so you can compare compounded monthly versus compounded quarterly versus compounded whatever, that there's some number to compare against. We're not doing future value. That gets to be a really complicated equation, and it gets really complicated. So for truck loans and all that, all you have to do is search for the internet of how much is my loan payment going to be if I need to buy this, I have this much down, this many year loan, and the APR is that. Okay? So let's go to the problems. Boom, boom. PreCalculus 3.6. Okay. All right, compounded continuously. I have this much principal, this is my rate, this is my time. I'm compounding continuously. My amount that I'm going to have in the end equals my principal, 3750, times e to my rate, 0.028, because you have to rewrite this in decimal notation, not a percent notation, and times 3. You just put it in your calculator and you go. Okay, I'm not going to work these problems out. I'm just going to set them up for you so you know what to do. If you're compounded annually is the amount times 1, and then 0.3% divided by 1 time per year is 0.3%, so it's 1.03 to the 5th power. Okay, you'd put that compounded annually. To find a simple interest equals principal times rate times time, which is 2,600 times 0.03 times 5. That's the interest, and then you have to add on your principal to that to figure that out. Okay, that's the amount that you get in the end there. Okay, so simple interest is principal rate time. This one is principal times 1 plus your rate to your time power. Okay, so know the difference. Again, another compounded continuously. So if it's compounded continuously, it's 27,000 times e to the 0.031 times 11. So if it's compounded 4 times per year, you'd start out with your $800, 1 plus, and then you put 0.05, change this to a decimal, divided by k, the number of times it's compounded per year, and then you take 9 times 4, the number of years times the number of times it's compounded per year. Oh, I should take problem 5 out. I'll take problem 5 out before I assign your problems to you. because we're not doing BB on these. Okay. Compounded quarterly. If you're compounded quarterly, which one of these four would you use? I equals P R E the T. I equals P times 1 plus the rate divided by the time, or number of times compounded to the number of times compounded times T. Do you add or subtract here if it's compounded K times per year? Add. You add. So you do that. Now, you want to see how long it'll take for the 2300. How many years will it take for the 2300 to equal 4140? So what you do is that 4140 equal to 2300 times 1 plus 0.09 divided by 4 to the 4t power. How do we solve this if it's as an exponent? We have to use what we did do the first section today. Logarithms. First thing we do is divide by 2300. Somebody, calculator, help me out here. 4140 divided by 2300. Going to be a decimal. Give me a 2. Give me a couple more decimal places. 1.8 perfectly. All right. Equals 1 plus 0.09 divided by 4. 0.09 divided by 4 is 2.25, I think. So this is 1.225, 1.0225, yep, to the 4t power. Well, if I log both sides, I can put that 4t out in front. So log of 1.8 equals 4t log of 1.0225. Then divide by 4, and the log of 1.0225